Yes, good morning, good morning, good morning, good morning. All fine? Good morning. All good? Okay. Yes. So, ah, okay, very good. Yes. Good afternoon. Okay, yes. Okay. I came at the time when good morning was there. Okay. Uh, so, yes, I said I'm always fine, all time good, okay, all time fine, and you have to be also fine all the okay. Always you must be fine because no one actually cares, okay. Yes, okay. Rolex, okay. Uh, so we are 5 minutes early. I said we'll start from 12 actually, but I think okay, next class onwards we'll start around 12, okay. Around 12 we'll start, okay. Today also started, but you didn't came, so I was just chilling. So in last class, what we have done? What things we have done in last class? What was completed? Is what was the last question we have done? And KTG started from where expansion of gases we have written, idle gas we have written, expansion of gases. From there only KTG started, okay? And this week you will get from the beginning. This week's syllabus is from the beginning, okay? Means where we have written the expansion of gases, gas law, okay? Charles Boyle, Gay-Lussac, from there only syllabus is there, okay? Last time these things were not asked. Now this week you have to prepare syllabuses, okay, from the okay beginning of the gases where we started. So in last class percentage based question we have done, na? All percentage based questions. And after percentage based question, I hope we did this question also. Vp square equal to constant, this was done. A gas follows Vp square equal to constant, this question. This was done. Vp square equal to constant. Constant PVT problem. Okay. This is not done. Okay. We'll start from here. Okay. So, right. Okay. Done this one. A gas follows. I hope I remember. Okay. We have done this one. A gas. Okay. Like this one. A gas follows. Okay. Vp square equal to constant. This question. A gas follows Vp square equal to constant. Okay. If gas is heated, its volume double. This question, its volume doubled. Okay. So this is the question that we have to find that okay, a gas is there which is following this route. Okay, Vp square equal to constant, and okay, its volume is doubled here. Okay, they're asking find final temperature. Find final temperature. Okay, so we have to tell final temperature in this question. Listen here. Okay, again I'm saying in this question completed in offline. Yes. Okay. So we can say Vp square equal to constant. Any relation can be given, but if you see in the question, they are talking about volume and pressure. They are talking about volume and pressure. Okay, here they have given. They are saying volume double, and they are asking no. They are talking about volume and temperature. Relation is given between volume and pressure. Okay, and in question they are asking that volume is doubled and what is the temperature. Means we need to find relation of volume and temperature relation we have to figure out. Okay, out of this PV equation is given here that Vp square equal to constant. So you'll say, sir, Vp square equal to constant, but I need relation of volume and temperature. Then only I can guess what will happen here in this one. Okay, so you can say Vp square equal to constant, gas is heated, volume doubled, find final temperature. Vp square equal to constant. Okay, I can use PV equal to nRT. I don't need pressure. So you can say, sir, I can substitute here. Pressure will be equal to nRT by V. nR is constant here. So in place of pressure, I can put here T by V, okay? T by V I will put. So you can say, sir, V, P square will be here, T square by V square equal to constant. So now we can say it becomes T square by V equal to constant. And finally, we can say V proportional to T square. So this is the relation that we obtained here. We got this relation. We are going to use this one. And listen, this question is okay important, but this method is very important. That conversion already in the previous class also I said when we were doing the expansion of gases. At that time I said when conversion of PV into VT, conversion of VT into PT means three things are there: PT, VT, and PV. All these interconversion you have to find. So now we can say in this one, once we got this thing, we get V1 by V2 will be equal to here T1 by T2 whole square. Okay. Now we can write in this one, okay, it becomes V1 is your V, okay, they are saying that initial volume I can take V, final volume will be how much your 2V, because volume is doubled, so final volume will be 2V. Initial temperature I can say that is a T, so we can say V divided by final volume 2V. Initial temperature T and final temperature is T2 that we have to find. Now we can say, sir, VV will be cancelled, right? V and V cancelled, so we can say this cancels, so it becomes here, okay. If I take the root, then you can say, sir, 1 by root 2, and becomes here T by T2. So from here, finally, I can say T2 actually becomes root 2T. This is the answer, okay. T2 becomes root 2T, okay. Yes, clear this question? If I give you any relation, I can ask theoretical question also. I will give you this relation, PV square equal to constant. I will say, if temperature increases, then what about the volume? Okay, I can ask theoretical question here. Temperature more about the volume. Yes, sir. V proportional to T square. If temperature more, volume will be more. Because a gas expands, it will cool or heat. We can say gas expands means volume is increasing. It means temperature also increasing. Can you answer like this? Theoretical question also we can do other than numerical, because three questions are theoretical, graphical, numerical. So this was the numerical, okay. Now I will tell the graphical question, okay. Or theoretical also I can say. Theoretical question will be like this: T more, it means V more. I will give you one question for the practice also. Theoretically you have to tell me the answer for that. So I am going to say some of the graphs. I hope this one is clear. Are we ready for the graphs? When I said graphs, we cannot mug up. We have to learn these graphs. Okay, so I will write in this one. If you say PV square, okay, or we can say VP square equal to constant. First graph they are asking, what is the graph between volume and pressure, okay? And you know that volume and pressure graph is asked here in this one. We can say volume or pressure volume, anything they can give you, okay? So we can say volume proportional to 1 by P square. Here you know pressure increases, volume decreases. And whenever pressure increases, volume decreases, you can say the graph is going to be like this always, okay? Whenever one increasing, other decreasing graph, this way you have to draw, okay? Can we draw like this? This is the first graph, okay? Second graph I am asking here in this one, that is basically your V proportional to T square. And if V proportional to T square, then what are the graph between volume and temperature? So we can say graph between volume and temperature, here volume and here temperature. If you remember, I have told and you have seen in the graph also that whenever y square proportional to x or x proportional to y square is there, then one will have it will be the parabola. It will be parabola. V proportional to T square, when one is having the power, no, it will be the parabola. In the graph, it was told to you. 1 power 2, other power 1, it is a parabola, okay? And in the parabola, one will have the power, other will have the graph, okay? One will be having the power, other will be having graph. So if you see here in this one, power is with the T. T is having the power. If T is having the power, it means graph will be towards graph will be towards V, volume axis, okay? So I can say here T is having the power, so graph will be towards V. So graph parabola is always like this. This is the your parabola shape. So I can say it will be like this, okay? U shape you can say, okay? U type is the your parabola type like this, okay? Now, if I say in this one, negative temperature is possible because this temperature I am writing in the Kelvin. In the Kelvin, temperature can be negative. Negative temperature is possible in the Kelvin. In Kelvin, negative temperature is possible. No. In Kelvin, negative is not possible. So what I will do, this negative side graph will not exist. So I will, okay, just erase this part because negative side will not be there. So graph will only, this part will exist. Okay, clear? Two graphs clear here, okay? Then third graph I am asking here, sir, what will be the graph between pressure and temperature? Means here, this is the pressure and this is the temperature. Can you tell me this graph, pressure and temperature? This is the thing, okay? If I am asking pressure and temperature, you have 30 seconds, not 30 seconds, 20 seconds. Tell me fast. Pressure and temperature graph, okay? Let's see who will answer fast. Sajid, yes. Yes, Sajid, last time you got maximum marks. So tell the answer fast. Blesi, straight line. And Sesagiri, straight line. Sella, straight line. Whether this will be the straight line or hyperbola or rectangular, means parabola. Hyperbola, straight line or parabola. Three things you have to say, P and T. First, you have to find pressure and volume, pressure and temperature relation. Pressure and temperature relation is not given. Like volume and temperature relation, we derived. See how to derive relation of pressure and temperature. Then only we can solve. Pressure, temperature relation you have to derive. Okay. Just like we derived this V proportional to T square. Then only we can, okay, we can move forward. Yes. Listen, I will write, okay? I will say Vp square equal to constant, okay? So I can say how to, I get, okay? I need pressure and temperature. If I need pressure and temperature, so I can say, sir, PV equal to nRT. So from here I can write, I need to now substitute volume. So from here volume will be equal to, you can say, sir, nRT divided by P. Means in this one volume I can substitute with this thing. nR is already constant, so I can say in place of volume T by P into P square equal to constant. So yes, sir, Tp equal to constant. It means P proportional to how much? 1 by T. And P proportional to 1 by T means temperature more, pressure less. And you know when one more and other less, okay, one increasing, other decreasing, it is going to be rectangular hyperbola, okay. It is going to be a rectangular hyperbola here. So you can say it is like this, okay. This will be the graph. I hope all three graphs are clear. Sometimes relation will not be given to you. And if relation is not given to you, then you have to find that relation, okay. Here in this one, relation was given in the volume and pressure. We got volume temperature also as well as volume pressure also. Clear? Can I go for next? Next question. Okay. Can I give you, okay, one question I'm going to give you. Theoretical question. Theoretical question will be like this, okay? They will say that if temperature more, then what about the pressure? Like this, okay? Anyone want to ask something here in this one? Huh? You want to ask something? Ask fast if you want to ask something. No? How it is possible that, okay, you are getting all the things, okay, not asking anything, okay, I am saying something and you are getting, at least there must be some doubt. No doubts coming. Relation will be given to you, okay, like I am giving in the next question, okay, they will give you a relation, one relation they will give, other one we have to, okay, find, okay, one will be given always, other we have to figure out, okay. So you're getting all the things, whatever I am saying. Whatever I am saying, you're getting all the things? Yes? Okay, so if this is the case, then I am going to give you one question. I am going to give you one question, and you have to tell correct answer for this. If you are able to get correct answer, okay, then I will assume that you are getting all the things. Otherwise, I will assume you are not getting anything. Okay, so this is the question here. Okay, they have given PV power 1 by 3 equal to, okay, or PV power 2 by 3, I can say here. PV power 2 by 3 equal to constant. Okay, if gas expands, then its temperature, okay, then you have to say options are, okay, then its temperature increases, decreases, and number 3, anything is given. Okay, increase or decrease, both are okay, like this, but 2 options are given. Okay, or this is the, okay, remain constant. Okay, constant, and 4th one we can say anything. So this is the question, that gas expands. Gas expands means volume increasing, and they are asking about the temperature. Means you need relation between volume and temperature. You need relation between volume and temperature. Volume and temperature relation you need here. Okay, and if you get this relation, then you will be able to get the answer. So make it fast. First volume and temperature relation you need, then only we can solve this question. Increase, decrease, we got here 2 options till now. Increase, 2 people are saying increase, now more people are saying increase. Okay, what about others? Make it fast. Increase or decrease? Increase. Mostly people are saying increase. Let's see what will happen here in this one. So we can say, sir, I need relation between volume, because expansion, and temperature. I will use the same thing, PV equal to nRT here, and then I can say pressure, I will, okay, substitute. So nRT by V, so I can put here in this one that nR is constant, so I can say T divided by V into, I can say here in this one, V power 2 by 3 equal to constant. Then you can say, sir, V and V power 1, okay, here 1. So T divided by V power 1 by 3 equal to what? Constant. I hope this calculation is clear. Here V power 1 and 1 minus this, okay. So now we can say this will be actually equal to T proportional to V power 1 by 3. This is the relation. Or you can say, sir, like this, V proportional to T cube. And this clearly tells that if volume more, temperature will be also more. Okay, volume more, temperature more. Clear? Temperature more, volume more. Okay, this is the 1 now. This will be coming downside. So 1 minus 2 by 3. So 1 by 3 will be left. And then T proportional to V power 1 by 3. Okay. Yes, can we do questions like this? Now, can we go for next? Okay, very good. Okay, listen, whenever in any question they give open mouth, okay, so open mouth, you have to remember that pressure will be always outside 1 atm. So here also will be 1 atm. If here pressure increases, then what will happen? If here pressure increases, then gas will go outside. Okay, and if here pressure becomes less, then gas will be coming, okay, from outside, air will come inside. So pressure will be remain always constant, means that will be the 1 atm. So whenever you have the open mouth, okay, they give open mouth container, then all the time you have to remember that in the open mouth container, okay, we know pressure is constant. Open mouth pressure is constant. How much? You're basically 1 atm. Okay, pressure will be constant. And whenever they don't change the container, if they are not changing the container, then volume is also constant, because in our gases volume is always volume of container. So if container is not changed, then volume will be also constant. Okay, container not change, volume will be also constant. Clear? Container same, volume same. Container same, volume same. You can remember like this. Okay, so let's write the question now. Okay, open mouth container. This question we have written open mouth container. I remember, I think this one didn't. okay, an open mouth container contains some air at 60 degrees Celsius. 60 degrees Celsius, okay? If it is heated to temperature T, 1/4 part of air, okay, 1/4 part of air escape out. Find temperature T. This is the question here. Find temperature T. Okay. See this one. That in a container, this is the open mouth container. Whenever you see an open mouth container, then we say pressure is going to be constant. And the container is same, so volume is also going to be constant. Okay. Open mouth container, pressure will be constant, volume also constant. Two things are constant. And we can say in the open mouth container, some air molecules are there. Okay. Initial temperature for this one is 60 degrees Celsius. You have to add 273 all the time. Temperature must be in the Kelvin. Remember again, temperature you have to take always in the Kelvin. Okay, you cannot take, if they have given answer on the degree Celsius, then also you have to take temperature in the Kelvin. You can convert later on. Okay, so we said T1 is 60 degrees Celsius. It means in the 273, if you add that 333 Kelvin. Okay, initially mole I can say that is the n mole. Now because in this one equation is then a PV equal to nRT, and in the PV equal to nRT, your R is same, pressure volume same. It means okay, n and T only changing. So we can say NT equal to constant. It means N1 and T1 equal to N2 T2, only moles and temperature changing. Whenever we are heating, some of the molecule will go outside. Okay, so this is given. How many molecules are going outside? 1/4 going. Okay, 1/4 moves out, 1/4 escape out. How many will be left then? You can see, sir, 1/4 out, 3/4 left. Okay, so 3/4 means N2 I can write. N2 means remaining mole. Whatever mole is there in the container, we are interested in that. Okay, whatever mole is there in the container, that we can say N minus N/4, 1/4 over, so 3N/4, and temperature T2 we have to find. So we can put here in this one N1 T1. N1 is basically N, the 333. And here we carry 3N/4 because 1/4 out, 3/4 left, and T2. So now we can say, sir, NN cancelled. This will be how much here? 111. So T2 you can write, it becomes your 444 Kelvin. Okay, T2 is 444 Kelvin. If they are asking the degree Celsius, then what you have to do? 444 minus 273. So you can say, sir, 444 minus 273 becomes how much? 171 degree Celsius. Okay, 444 means 171 degree Celsius. Okay, can we do? Okay, so this was a very basic question. Here two things were constant and two things were variable. Pressure volume was constant. Why pressure was constant? Because in the open mouth, okay, pressure constant, container same, volume is constant. So we can say moles are changing, and 1/4 part out, so we can say 3/4 left. So N1 T1 equal to N2 T2. Are we ready for the next question now? Yes. Today we have to solve around, okay, you can say roughly around 7-8 questions we have to do. Already, okay, 2-3 questions we have done. 3, okay, done actually, 3-4, yes. So let's do more question, okay. Completed. If I say balloon is there, okay, so in case of balloon, volume of balloon will be fixed or changing. Right now I don't have balloon, otherwise, okay. So volume of balloon will be fixed or changed. What do you say? Change. Okay, so next question is based on that thing here. Okay, but inside balloon whatever, okay, inside balloon whatever gas is there, that mole will be constant. Okay, like if I say this is a balloon, okay, so we can say in this one whatever the moles will be there, that mole is going to be constant. Okay, so right, okay, balloon contains 1000 cc helium at 27 degrees Celsius and pressure, okay, and pressure P, okay, 1000 cc helium, or I can say pressure 1 atm, okay, and pressure 2 atm, okay. Balloon contains 1000 cc helium at 27 degrees Celsius and pressure 2 atm, okay. If temperature and pressure becomes minus 3 degrees Celsius and 1 atm, find final volume, okay. So we have to find final volume here. You can say in this PV equal to an RT, if I write the equation, then how many things are, okay, always you will write like this, and then you will figure out how many things are changing. You can say, sir, pressure changing, volume changing, temperature changing. What is not changing here is the mole. Mole is constant, okay. We can say mole is constant here, okay. P1, if I say, so we can say P1 is going to be 1000 cc, okay. If I say, no, not P1, it means volume, okay. So you can see here volume is going to be 1000 cc. Temperature, if I say 27 degrees Celsius, means 300 Kelvin. Pressure, if you say, that is your 2 atm. Finally, what is there? Temperature becomes minus 3 degrees Celsius. Minus 3 degrees Celsius, if you write in the Kelvin, then we get how much? 270 Kelvin. And final pressure is given here 1 atm. And final volume we have to calculate, okay? Yes. So you can say, sir, only mole is constant, R is constant. So I will write the relation P1 Y1 divided by, okay, P1 V1 by P2 V2 equal to T1 by T2. Listen, this one is in the ATM, this is also in the ATM. So will be cancelled. So no conversion required, okay? Actually, I don't need the conversion, okay? So I can put a value P1 is here 2, V1 is 1000, divided by P2 is 1, V2 I have to find. T1 if you say 300 and this one is the 270, okay, you can do the calculation fast, okay, you can solve faster than me. We can say one more zero will be cancelled here, so 3 and this will be 9, and 9 and 2 will be 18, so V2 we can say finally 1800 cc, okay, 1800 cc. See this question, if anywhere any doubt is there, ask fast. Otherwise, we'll do the next question now. Okay. Ready for next? Next question. Means we are writing these questions so that you will get some idea how to apply PV equal to NRT, because questions you have to solve, okay? In last class also we have done some question. Again we are doing some questions. So you have to get some, okay? In your, okay, brain is going to identify how to proceed for the questions, okay? Whenever any new question will be coming, okay, automatically brain picks the values, it will decide what we have to do. We not to convert volume into liter. Listen, volume is in the cc, so I got answer also in the cc, okay? It was there in the cc, so answer in the cc. So they are writing answer in the your meter cube, then we can convert cc. So conversion not required, okay? Yes. Can we do the next one? Next. Okay. So next question, okay, listen this one also carefully. Okay, a container contains 12 gram O2, okay, 12 gram O2, okay, at pressure P and temperature 127 degrees Celsius, okay, at pressure P and temperature 127 degrees Celsius, okay. A small hole is made in it so that O2 leaks out. Okay. O2 leaks out. Okay. Whenever a small hole we are making, it will ultimately gas will leak out. Everyone knows. Means small randhram is there. It will leak out. O2 will leak out. Find amount of O2 leaked out. Leaked out. They are not asking remaining, they are asking leaked out. So underline this thing. Leaked out. In which question you are asking, Kaniti and constant? In which question? Previous question? In the previous question you are asking? If balloon is there, balloon I am not bust. If you are not busting the ball, balloon wall, whatever the gas is there, that gas will remain same. And if gas is same, then your mole will change or will not change. If gas remains same, then mole will not change, na? Okay. Yes. If molecules are going outside, then it will change. Like in the previous question, molecules were moving outside. It was changed. Here not moving. Molecules are I am not injecting any gas from outside or molecules not moving outside. So moles will be constant. And if I say here in this one, this question, amount of O2 leaked out if final pressure P/2 and temperature 27 degrees Celsius. Temperature is 27 degrees Celsius and pressure is P/2. So what we can write here in this one, we have PV equal to nRT is the formula. Now we need to decide what things will be constant. This is your one container. I am making one small hole here. You can say, sir, one thing is their volume will be constant in this one. But mole will not be constant because moles will change because some of the gas moves out. Some molecules are moving out. So in this case, moles are not constant. What is constant? Only volume. And they have given initially pressure was P. Initially temperature was 127 degrees Celsius, means 400 Kelvin. Initially mole I can say because initially 12 so 12 by 32 moles were there. Final pressure is given here P/2 and final temperature is given 27 degrees Celsius, which is the 300 K. And now we know final moles will change here. Mole will not be constant. So if m gram O2 leaked out, you can say, sir, if m gram O2 leaked out, then how much remaining O2 will be there? You can say 12 minus m gram will be left. Earlier 12 was there. Now m gram leaked out. If m gram leaked out, then only 12 minus m will be left. And if 12 minus m is left, then we can say what will be the moles? Yes, sir, moles will be now 12 minus m, m by mw. Mw is basically for the oxygen 32. If this is the nitrogen, then we get 12 minus m by 28. So now we can write all the values are there. We can just put here volume constants. We can say P1 divided by P2 will be actually equal to N1 T1 by N2 T2 because R is also constant. So P1 I can say P. P2 is your P/2, so will be going upside. N1 is your 12 divided by 32 and N2 I can say how much N2 here? 12 minus m by 32. Some people do the mistake while putting the value. And 2 you have to put downside. So 12 minus m and 32. And then T1 I can say that was the 400. And this one is how much? Your 300. Now is 2020 cancelled. 32 also cancelled. 2 PP also cancelled. 3 you can say, sir, this 3 and this will be 4. So we can say now here 2 into 12 minus m equal to 16 means 12 minus m equal to we can write 8, and from here I can say finally in this pen it will be m equal to how much here 4 gram. So 4 gram oxygen will leak out. 4 gram will leak out. See the calculation. Veera, not 3 gram, 4 gram. Okay, I am asking how much will leak out. 4 gram will leak out. I assumed here that 4 gram will leak out. Check your calculation. Check your calculation. Okay, in this question I am asking how much will leaked out. So this much amount will be leaked out. Okay. If same question I ask with the nitrogen, can you do? Same question with the nitrogen, can we do? Okay, one question is there in the material for the nitrogen that you have to try. Okay, you will try that question for nitrogen. Okay. Now, ready for next question? Next one. Okay. So we are perfect in this pattern, means whenever this pattern is going to come, we can at least solve. Okay. Okay, very good. Next question, that this is for you. Okay, this is for you. A container contains 14 gram, okay, or I can say 14 kg here, okay, N2 at pressure 380 M, at pressure 380 M, okay. Some oxygen is added to container, okay, some oxygen is added to container, okay, so that final pressure, okay, becomes 980 M. 980 M. Okay, they have given temperature constant. Find mass of O2 added. Okay, how much O2 we have added? We have to find that mass. Okay. No, for the nitrogen, different calculation will be there. Okay, question is there, you will calculate. Okay, for the nitrogen, you have to calculate. Okay, so here I have given not nitrogen as well as oxygen in this question. Temperature they have given same. Other than temperature, what thing will be okay same, because this is the container. You can say in this container only I am mixing, so volume will be also constant. So two things are constant. If you say in this one PV equal to an RT, if you write now that sir here in this one temperature constant, they have given R constant, volume also constant. It means P will be proportional to N. This is the key point. This is the your okay hint for you. Pressure proportional to N. Now you have to try this question. Okay. Now get the answer for this. Syam 48, Manish 48. What others are saying? 48. Okay, so let's do this one. We can say what are the pressure, okay, for nitrogen, okay. Pressure for nitrogen is, okay, we can write here in this one. Pressure for nitrogen is actually equal to 380 M, okay, 380 M. Moles of nitrogen is, if I say, yes sir, moles of nitrogen will be your, okay, 14, okay, 14 divided by 28, okay, you can say sir 10 power 3 here, okay, so I am writing 10 power 3, but 10 power 3 will be cancelled, okay, so you can say this becomes your 10 power 3 divided by 2, that will be cancelled, okay, because we have to write in the gram, okay, so that will be cancelled, okay. Now we can say that pressure of nitrogen plus oxygen, so pressure of nitrogen plus oxygen is how much? Your 980 M, okay, 980 M is the basically pressure of nitrogen plus oxygen. So what is the pressure of oxygen? You can say the pressure of oxygen, nitrogen is 380 M, okay, total is 980 M. It means because of oxygen how much changed? because of oxygen, okay, earlier it was 3 atm, now finally 9 atm. So because of oxygen, how much increased? Because whatever the increment is happening, whatever the change is happening, that is coming because of the oxygen. So because of the oxygen, we can say that is the your 6 atm. Suppose I am adding here, okay, your okay, in this one m kg, so we can say n of oxygen will be equal to m kg. We say m into 10 power 3, okay, divided by 32, okay. 10 power 3 will be cancelled. So we can write from here in this one that pressure of nitrogen, okay, N2 divided by pressure of oxygen equal to mole of N2 divided by mole of O2. Let's put the value. Pressure of nitrogen is 3, pressure of oxygen is 6. Moles value I will put for the nitrogen are in 10 power 3 divided by 2, and for the oxygen we got here m into 10 power 3 by 32. 10 power 3, 10 power 3 will be cancelled. In the beginning only you don't write, okay. So now we can say here in this one, this will be how much? 3 and 6 will be 2. 2 also cancels. So we can say m becomes how much here? 32 kg mass we have added here, okay. We have added here 32 kg mass, okay. Yes, 2 will be cancelled, 32. Clear? Okay, some people might have done mistake because of okay, they have taken here 9, okay. That is the mistake you might have done. Yes, okay. Clear this one? Anywhere, any doubt? Pressure proportional to N. So pressure because of nitrogen divided by pressure because of oxygen will be equal to moles of nitrogen by moles of oxygen. So we have written 3 by 6 equal to this thing. Yes? Done? Okay. So can we write next question now? Next, okay. Next one is question on the bubble rise, okay. Bubble rise question, okay. You can write bubble rise. So we'll write question on that. If I say when bubble will be moving from, okay, bottom to top, bubble moves from bottom to top, then its volume increases or decreases. When bubble moves from bottom to top, then volume, what happens to volume? Volume increases or decreases? Volume increases, okay, because pressure at the bottom is always more. At the bottom pressure is more, so volume is always less. And at the top, okay, pressure is less, okay. So we can see here, okay, next question. They are saying in this one that this is the, okay, they will say some lake or something is there, okay, and this one, okay, what is there, okay, that here we have one, okay, bubble. When bubble will reach here, then of course its volume will be more. Reason being because here pressure is your P naught, which is the actually 1 atm and which is equal to 10 power 5 okay, Pascal, okay, which is equal to 10 power 5 Pascal, okay. Now if I say in this one, okay, 10 power 5 Pascal, here pressure if I say that the pressure will be P naught plus rho gh. Why? Because if this depth is h, then with the depth pressure will increase and pressure becomes P naught plus rho gh, okay, P naught plus rho gh here. So when it is moving from here to here, so I guess this is the initial pressure, I can give the name as P1, in here I can give this name as P2. So here pressure is more, that pressure is P naught plus rho gh. That's why here volume is less. This volume I can say as V1, okay. This is the V1 equal to V, okay. And here V2 equal to, they will say, okay, that volume becomes double, volume becomes triple, volume becomes 3 times, 10 times. We will always write PV equal to nRT, okay. Now they will give in the question the temperature is constant. This thing will be given to you. It means there is no major change in the temperature when it moves from bottom to top. Temperature remain almost constant. And whatever the moles will be, you know, mole will be constant. Whatever the, okay, mole will be there inside this bubble, that mole will be constant, okay. So we can say, sir, here in this one temperature and okay, these things are constants, means PV equal to constant. So we can directly use P1 V1 equal to P2 V2. So this is a very simple principle. We have to use P1 V1 equal to P2 V2. Now they will give the condition, okay, that initial volume, okay, final volume becomes double, final volume becomes triple, or something like this. Okay, I am giving in this question that suppose here radius is r, then here radius becomes 2r. Radius becomes 2r. So yes, sir, here if radius is there, na, we know v proportional to r cube. Okay, so volume v1 equal to v, we can write in the 4 by 3 pi r cube. Okay, v1 equal to v, that is 4 by 3 pi r cube. And here I can write v2 will be equal to 4 by 3 pi. Okay, this is the 2r cube. Okay, so if you find here in this one, okay, 2 cube will be how much? Your 8. Okay, so this one we can say v2 will be equal to, okay, 2 cube is 8 and 4 by 3 pi r cube. So this will be how much? Your 8v. I hope this one is clear. Array 2 cube will be 8 na, and 4 by 3 pi r cube. So we can say 8 and 4 by 3 pi r cube is v. So we can say v2 will be equal to 8v. Okay. Now I can put the values here. P1 is basically your P naught plus rho g h, and V1 I can say here in this one that is the your V. P2 I can say that is the, okay, your rho g means P2 is basically P naught, I can P naught. Okay, and we can say V2 is your 8V. Why V2 is 8V? Because volume becomes not volume, radius becomes double. In this question, if I give you radius become triple, suppose question is given radius becomes triple, then what will take? If radius is triple, then what will take? How much will be the volume? This is triple means 3 cube, and 3 cube will be how much of 27V. Okay, if they say radius becomes 4 times, if radius becomes 4 times, then what will take? 64. Okay, we will take 64V. This way we will solve the things. Now we can say, sir, VV will be cancelled. If you say this side P naught, this side 8P naught, so I can say rho g h will be equal to, okay, here 8P naught, this is the P naught. So how much? 7P naught. Okay, now how to put the value? Density for water in the SI unit. Density for water in the SI unit is, what is the density of water in the SI unit? 1000. Okay, at least you know. Okay, good thing. Okay, in CGS it is 1, otherwise 1000. Okay, in the SI unit thousands, we can say here I will put here 10 power 3, G value is 10, H is H equal to 7, P naught is your 10 power 5, so we can say 10 power 4, 10 power 5, so H finally becomes how much here? 70 meter in the depth they will ask, so they can give you volume directly, volume becomes triple, 4 times or something, or we can say they will give you like this, okay, that radius becomes double, triple, or some relation will be given. So we have to use P1, V1 equal to P2, V2, and P1 here P naught plus rho g h, volume is here your V, here we can say P naught, and this becomes your 8V. Can we do the things? Can we do the next thing, next question? Next, make it fast. If any doubt, ask fast. Yes. Okay. Okay, good. Okay, so now we'll do the next thing here in this one. Add. So in this one, question is here, okay, or we can write this heading first. Concept of mixture, okay. Concept of mixture means basically we are going to mix some gases, okay. Some of the gases we are going to mix here in this one. See, if I say in this container I am going to mix gas A, gas B, gas C, some of the gases are there. So you can say first thing is there, total mass, okay, total mass is going to be mass of the mixture. So we can say it is going to be nothing but the M1 plus M2 plus dot dot, total mass will be total, okay, we can sum total moles. So also if I say na, you say total mole will be equal to what your N1 plus N2 plus dot dot dot, okay, dot dot dot, okay. Now, if I say in this case, what is the total volume? So total volume is always volume of container, okay? Volume of container where they can move freely. So we can say this volume will be the volume of container. This is the volume of container. So V mixture will be equal to V all the time, okay? V mixture is V, okay? Now if say, suppose sometimes what will happen, they will join, okay, some of the container they will join like this is the one container, okay, and then there we got here, okay, these tubes are very thin, okay, and like this we have joined in this one gas A here, okay, having volume V1, gas B here having volume V2, gas C having volume V3. If you are joining, then we can say in this case, now for the molecule of A, okay, how much space is available? You can say, sir, V1 plus V2 plus V3 total space is available. For B also we can say molecule of B also can move in the whole space of V1 plus V2 plus V3. And for C also we can say total space V1 plus V2 plus V3 total is there. So in this case, if they are joining the container, whenever they join the container, then total volume is always equal to, so it's total volume is always equal to V1 plus V2 plus V3 plus dot dot dot. I hope you will not do this mistake whenever, because now for molecule of any of the gas, total volume V1 plus V2 plus V3 is available. Tube volume we are not considering because tube we are taking negligible. But if they give volume of the tube also significant, then you will consider that volume also because that volume is also available. Okay. And okay, that's it we have to do. Okay. Then we can use PV equal to nRT, okay? PV equal to nRT, clear? Now in this one, if I say here, do you know N equal to how much? Your M by MW. N is basically M by MW, hai? So from here I can say, what will be the mass? You can say, sir, mass will be equal to NMW, okay? Now, in this one, okay, M mixture I can write, sir, you can say N mixture into MW mixture equal to M1 I can say N1 MW1. This one I can write N2 MW2 plus dot dot dot. Okay, M1 and M2 I'm replacing here. Then you can say, sir, MW mixture formula if I say, so MW mixture will be equal to N1 MW1 plus N2 MW2 plus dot dot divided by N mixture. N mixture where go, okay, N1 plus N2 plus this. Okay, this one is clear. Yes, see this thing. Any doubt in this? Whatever is written on the board, anyone having any doubt? Can you do the next things? Some questions? Ready? Okay. So only thing, this thing you have to be careful that when we are mixing like this, the total volume will be V1 plus V2 plus V3. Otherwise like this. Okay. So let's write the question. Add. Okay. 14 gram N2 and 16 gram, okay, O2 are mixed in a container of volume 5 liter at 27 degrees Celsius. Find pressure of mixture. Find pressure of mixture. Okay, so this is the question here that we have to find the pressure of mixture. What we'll do basically, you can say, sir, I will use this PV equal to nRT in this one. And what is given basically, volume is given, volume is 5 liter. So I can say I will convert 5 into 10 power minus 3 meter cube. Temperature 27, so I can say this is going to be 300 Kelvin. Pressure is asked moles. Okay, so we can say total mole will be equal to N1 plus N2. Okay, total moles not given, so N1 plus N2. N1 I can say will be the 14 by 28 plus 16 by 32 because this is the nitrogen. 14 by 28 plus 16 by 32. So I can say 14 by 28 will be how much here? Half, and this is also half. So half becomes 1. So I can put here now everything in this one. The pressure we have to find. So pressure we can say nRT by V. Okay, whatever you have to find for that formula we can write. Now we can say in this one N is 1, R is 25 by 3. Okay, because we know if I take the decimal, then calculation will be there. Okay, 20 by 3 things can be cancelled because we prefer in the fractions. temperature is 300, okay, and I can say this volume is your 5 liters, so 5 into 10 power minus 3, which is 3, this will be 100, and this 5, so this will be the 5, so we can write 5, and this 10 power 3 will go upside, so it actually becomes 10 power 5 Pascal, and this can be written as 5 ATM also, okay. So I hope this is okay. Clear this thing? This one is done. Okay. So when we will use R equal to 0.0821, 0.0821 you will use when ATM liter. But in physics, okay, we have one rule that we'll use everything in the SI unit, okay, so that we are not confused. Otherwise, what happens because of this, sir, when to use 25/3 ATM liter, we are doing mistakes. In chemistry, somewhere, some questions they have given, okay, some answers they have given in the ATM liter. Okay, and because of that, okay, we remember so many things. But physics, all the time we have to do calculation in the SI unit. Later on, we can convert. Okay, so that is for the ATM liter. Okay, Rakesh, for the ATM liter. Okay, some questions in the chemistry. Okay, but everyone is using the SI unit, so we have to prefer most of the time SI unit. But if option is there, then we can see. Okay, if I ask second question here, I am asking about the density. So you can say, sir, density means your rho is equal to mass by volume. Mass is how much? You can say, sir, mass in this one is given 14 and 16 summation. How much? 14 and 16 is your 30. So 30 into 10 power minus 3 divided by, I can say, volume. Volume is how much? Your 5 liters. So 5 into 10 power minus 3. So we can say this becomes your 6. Okay, 6 kg per meter cube. Okay, clear this thing? Done? Finished? Yes. Okay, some more questions we have to write. Can we write one more question? Or we are stopping here? Okay, stopping here because, okay, in other batches also we have done up to this. Okay, so okay, some graphs can I tell? Some okay, some small graphs. Okay, so listen, if anywhere, if I give you now, this one I have told you earlier, if you say the two lines are given, P1 and P2, then which one is more? This rule already told to you, P1 and P2, which one is more? P1 and P2, this was told, no, earlier that we will draw a line, okay? Because now whatever I'm going to say, you should know, okay, P1 is more, okay? This answer you should know, okay? P1 is more. Means P1 is more than P2, and everywhere, here pressure, here pressure, here pressure. If I know point A, point B, here point C, and here point D, then everywhere we can say, okay, that PA equal to PB equal to what? P1, and PC equal to PD equal to P2, because everywhere pressure will be P1, and here at all the point pressure will be P2. Okay, so they will give you options. Okay, and what options they will give you? They will give first option like this, that which of the following, okay, which is incorrect, you have to select. Okay, select incorrect. Okay, this will be the question. So they will say PA equal to PB. Number 2 option, PC equal to PD. Number 3 option, they will give you PA more than PD. 4th option, PC more than PB. Which one is incorrect? Which one incorrect? They will give options like this. Yes? Which one incorrect? Answer is 4. Okay, I hope this one is clear. Can I say one more question now? One more like this. Okay, so I will tell one more. Okay, this way, make it fast. Okay, then one more. Okay, Suppose if I give you this thing, okay, here they have given in this one that this is the, okay, pressure and temperature, same thing they can say two graphs are there. This graph is at the VA and this is the at the VB, and they are giving some points here 1 and here 2 and here 3 and here 4, and they are saying in this one, okay, that first one, okay, so we know, everyone knows that actually we know this conclusion, V1 equal to V2 equal to VA, and we know this thing V3 equal to V4 equal to VB, and we know one more thing that VA here, we know VA is more than VB, okay, we know this thing, okay, this thing is already told to you in the previous classes, okay, here pressure, here volume, everywhere same, okay, so options, okay, select, okay, they are giving now correct, okay, select correct. So number one option they have given V1 equal to V3. Number two option, V1 is more than okay, V2. Number three option is given here, V4 is okay, more than V1. And number fourth option they have given in this case, V2 is more than V3. Which answer? Which answer is correct? Here you have to take the correct one. Which is correct? Which is correct? Answer is? Three is, VB is less, na? VB is less. How 3 can be correct? V4 is 100% less than V1. Okay. Someone is saying 2. 2 V1 more. This is the V1 and V2 both are same. Okay, V1 and V2 both are same. With respect to this, you have to say answer is only 4. Okay, answer is 4. Clear this thing? Completed. Can I say one more question? One more? Okay. Listen, if I give you this thing, here volume and temperature, you know 100% that if I ask about these 2 points, okay, these 2 points, okay, this point is your okay, suppose A, this point is B, and if I say where pressure is more, at A or B, at A or B, where pressure is more, at A or B, in this one, A or B, you can say 100% answer is A, okay. Now what I will do here in this one, okay, I will just erase this, I will erase this line, okay. So what is left? Only A and B, and for A and B, okay, I will put line, okay, I will put the line like this, okay, means this way I can put the line, okay, yes, means like this, okay, this is the, okay, you are feeling, okay, that line is straight line, but this is not the straight line, A and B, okay, like this, it is not the straight line, okay. So A, B, they will say when we move from A to B, what happens? You can say, first thing in this one I can say, where volume is more, you can say, sir, volume at B is more than volume at A, here, okay, here volume is more, this thing we can say from the graph, volume is more, okay. Where temperature is more, where temperature is more, because temperature is more at A or B, temperature is more at A or B, temperature, because temperature at A will be this much and B will be, okay, here, so temperature at B is less, okay, so you can say temperature at B is less than TA, okay. And what about the pressure? So pressure we can say, for the pressure is the more critical, because you cannot say from the graph directly, so we can say we will draw a line like this, we'll draw a line like this, we can say here pressure is okay, PA, and here pressure is PB, and we know that when PA, PB, two lines are given, so PA is more than PB. Can you do like this if they have given this line? Okay, so these 2 points are given, so point A and point B, we can join from the origin, we can make graph like this. So we can tell about the all parameters, about the volume, about the temperature as well as pressure. Okay, one more question now, one more question based on this, because one more question will give you more clarity here. Okay, some more clarity will come. So if I say now in this one, okay, this one is the, okay, here pressure, this one is the temperature. If I am giving line like this and one line here, okay, and this one I am taking, this is, okay, one point here, and I am taking 1 point here, okay. These are the 2 points, one here and one there. This point is A and this point is B. They're asking where volume is more, at A or B. Where volume is, means no, first they are asking pressure. Where pressure is more, at A or B? Where pressure is more? You see, sir, pressure I can directly find at A pressure is this much, at B pressure will be this much. So pressure is more at the, okay, later on what they will do, they will just remove the line. Line will be over. Only this will be given and they will say line like this. Okay, this is the line given. Okay. And now in this one, they will ask where pressure is more when, okay. We can say 100% in this case, pressure at B is more than pressure at A. We can see from the graph. What about the temperature? What do you say about the temperature? Where temperature is more? Temperature at B is more than temperature at A. Temperature at B is more than temperature at A. And if they are asking number 3 about the volume, so for the volume, then what you have to say, you will join from the origin. I will join from the origin like this. I will join from the origin this way. And then I will join this one also, okay, like this. We can say this one is the VA and this one is what? VB. And now you have to tell which one is more, VA or VB. Now which one is more? You can say in this one volume is, of course, this one is more. Okay, so we can say here, okay, VB is more than VA. Because I said now this line is there now, P and T. If I give you 2 lines like this, okay, this is the VB, this is the VA. Which one is more? We know VB is more. Okay. Means these are not the direct graph, okay? These we can say derived from the previous one, okay? Where previous things are, you miss. If you know the answer of the previous one, then we can solve. I hope these things are clear. Yes. Finished. So can you try these questions if comes in the examination? Yes. Done. All done. Anywhere, any single doubt? Any single doubt in this one? No doubt. Okay, good. Now, okay, enjoy, chill. Do some question, ideal gas question you have to finish, okay? All question of ideal gas you have to finish, okay? QR code is here, okay? You got your QR code, finish all the questions, okay? This will be the QR will be coming now. Okay, so bye, okay? Enjoy your day. Okay, do all question in the examination, okay? All question. And how you can attempt all the question? Before that, you have to do practice. PV equal to NRT, okay? Get perfection. Are there any classes tomorrow? Miss, I don't need, okay? If any classes are there, it will be notified to you, okay? You will get the notification if classes are there. So, okay, but do your questions. Enjoy, okay?